Hello. So today we're going to talk about subscripted variables, which looks really complicated and makes us have a lot of letters in our problems, but it's really nothing different than what we already know. It's just another way of writing equations to make the variables more obvious. It helps us to know what those variables actually mean. So let's look at something that we've already done before. With this set right here, we have two different equations, and it says to solve by substitution. So in order to solve for this by substitution, I'm going to have to solve for either x or y, and then plug in that value to the other equation to be able to solve for the second variable. But let's say that this set of equations matches a word problem. And in that word problem, x actually means the number of nickels. And maybe that y actually stands for the number of dimes. It may get kind of confusing if we leave it as x or y. So an easier way for us to write this might be to say the number of nickels or the number of dimes. And we've already used n to show number. It just means a number. But in this case, we would have to use n twice. One n for number of nickels and one n for number of dimes. So that doesn't really help us clarify it at all. So we're going to need to use a subscript, which is kind of like the opposite of an exponent. So the exponent is small and on top. A subscript is small and on the bottom. So if I want to say the number of nickels, I might do n for number with a subscript n for nickels. And for number of dimes, I might do a large N for number of and a subscript D for dimes. So I'm just going to change those x's and y's in the equation so that they now are n for number with their subscripts. Okay, so now that we have this, it's easier for us to read and actually comprehend what's happening in this equation. So 5 times the number of nickels plus 10 times the number of dimes equals 125. And the number of nickels plus the number of dimes equals 16. So that would mean I have 16 total coins. And I don't know the amount of nickels and I don't know my amount of dimes, but I'm going to be able to use substitution to figure out what the number of nickels is and what the number of dimes is. So I'm going to choose to solve for the number of nickels in that bottom equation there, just because this bottom equation looks the easiest to solve for one variable first, and I just chose nickels because it seems fun. So let's solve for that by subtracting the amount of dimes here. Let me rewrite my equation first. Equals 16. So I'm going to subtract this and get rid of it over here and then put it over here. So then I end up with the number of nickels equals 16 minus the number of dimes. And now I can take this value and plug it in for the number of nickels in my first equation. So I'll rewrite that over here. We have 5 times the whole number of nickels, which was 16 minus the number of dimes, plus 10 times the number of dimes equals 125. And now that I have all the same variable, I'm able to combine all these like terms. I made it so that I have like terms to combine. So I'm going to have to do some distributive property over here with this 5. 5 times 16 is 80 minus 5 times the number of dimes plus 10 times the number of dimes equals 125. Now I'm just going to move left to right, combine those like terms. So I end up with 80 minus 5 plus 10 is a positive 5 number of dimes. Still equals 125. Let's put that 80 on the right side of my equation. And I end up with 5 times my number of dimes equals 45. Then I just divide by 5 to get that number of dimes alone. And then I get number of dimes is equal to 9. So I know that I have 9 dimes. And now let's go back to this beginning equation that I had. I knew that the number of nickels plus the number of dimes was a total of 16 coins. And now I know that 9 of those coins are dimes. So I'm easily able to figure out what the other amount is, what the nickels are. So if I have 9 dimes and I have a total of 16 coins, then I know that I have 7 nickels. because 7 plus 9 is 16. So my number of nickels is 7, and my number of dimes is 9. And I did it. That is my answer. So it's really just the same thing we did before when we learned substitution. The book just wanted to make it a little bit more confusing by throwing in some extra letters for you, but really it's not that bad. It's just going to help you understand what those variables actually mean. Okay, so this time we have the same kind of setup as before. We have two equations, and they want me to solve for the number of nickels and the number of quarters using this equation, and they also told me to use substitution to solve. Now, this is actually a really nice setup because they already tell us what one of those variables is. They tell us that number of quarters is equal to the number of nickels plus 2. So there are 2 more quarters than there are nickels. So I can take this whole value and plug that in for the number of quarters right here. So let me rewrite it by doing that. I have 5 times the number of nickels plus 25 times the number of quarters, which is the same thing as saying the number of nickels plus 2, and that equals 290. And now I have all the same variables, so I can solve from left to right. But first I'm going to have to do some distributive property here. So that'll become 5 times the number of nickels plus 25 times the number of nickels plus 50. 25 times 2 equals 290. Put together those like terms, so I end up with 30 times the number of nickels plus 50 equals 290. Then I'm going to have to subtract this 50 over here, subtract it over here, and I get 30 times the number of nickels equals 240. One more step, I'm running out of space. Divide by 30 over here, divide by 30 over here, and then I have that number of nickels alone finally, and I know that my number of nickels is 8. And if I look back up here, I saw that the number of nickels plus 2 is my number of quarters. So I have 2 more quarters than I have nickels. So if I have 8 nickels, then I know that I have 10 quarters. And then we did it. We were able to solve this problem.